Welcome, guys, to another ChronoLogic webinar. Joseph here, and I have Peter here with me. Peter, say hi to the guys.
Hey, hello, community.
Hey, guys. So me and Peter will do a small live stream today. Hope you guys are excited about this. We're going to be talking about second layer execution markets. Namely, Peter will go through a small presentation that he made for an upcoming event at Ethos, and this will be kind of like um, a similar thing. So hopefully you guys are excited about this topic, and let's get into it. But before we get into the second layer execution markets, let's go through a couple of updates. So what we have is the new releases on the app ChronoLogic.network, new releases of our DApp with the Electron. So the latest release is 1.0.0-RC2, which is mainnet compatible, and it has a number of stability and performance improvements. So hope you guys have probably already tried it out and seen it, but we're really excited about this release. Another release we have is the CLI, which CLI TimeNode, which also includes the new dashboard that Logan has been working on. We've seen your guys' reactions on Telegram. You guys seem to like it, and it seems pretty slick, right? Also, we have a couple of new commands, .request info and .network within the command line. The latest really update that we have here is the new version of the TimeNode core library, which has a new engine for statistics. And the aim with this engine was to kind of expand on the existing statistics capabilities of any clients, which include both the DApp and our CLI. And hopefully it will give more insight on all of these scheduled transactions that have been scheduled by the users, and how they are being managed, and which of them are being claimed, which of them are being executed, how many has your TimeNode, how many transactions has it claimed, how many transactions has it executed, how many transactions has it tried claiming, tried executing. And this will give like a greater insight on how your TimeNode is actually operating. And of course, a number of stability and performance improvements. And this is just as we get closer to the final 1.0 release, we are kind of like finding certain squashing and any kind of inconsistencies with the performance. Another update we have for you guys is that ChronoLogic will be presenting at Ethos, Ethereum Industry Summit in Hong Kong, and this will happen on September 8th, which is pretty close. So this is something Peter is going to this event, and Peter will be presenting on second layer execution markets at this event. So we're pretty excited about this. So if any of you guys will be in Hong Kong at that time, be sure to check it out. Peter will be presenting alongside Vitalik and other guys from the Ethereum ecosystem, Ethereum industry. Parallel to this event, we have another event that ChronoLogic is presenting at, and this will be ETH Berlin. So ETH Berlin has a number of different tracks. One of them is the hackathon, and ChronoLogic has partnered with Polymath to attend this hackathon and to build some cool stuff on it. So keep in tune, and we'll keep you posted on how the hackathon is going. Follow us on Twitter if you haven't already, and our Telegram channel, and we'll post some updates on how the hackathon will be kind of going. So this will be on September 7th to September 9th in Berlin. And of course, the latest update that we have is that we are getting very close to the final release of the Ethereum alarm clock and corresponding all of the tools. So hopefully you guys are really excited. I've seen some of you guys have have seen the activity that has been going on lately on GitHub. So this large amount of activity is mostly due to the upcoming release, which is bound to be very soon. So you can follow our progress on GitHub as well. Peter has created a milestone with the issues that we're currently fixing, and once these issues are fixed, there will be another release, which will be release candidate 3, and should we find no other bugs on that release, it might be the final release. But keep posted on GitHub and check out our progress there. So that said, I'll give it up to Piotr. So Peter, yeah, go ahead. The stage is yours.
Okay, so am I the presenter? Do you see my presentation, or shall I screen? Okay, I guess now it's fine.
Yes.
So,
yes.
all right, thank you, Joseph. Yeah, so as Joseph mentioned, I got a speaking spot at the conference in Hong Kong, so I'm pretty pumped and excited to basically get into the second layer execution market. And obviously that's something that the idea is emerged from our experience, our work on Ethereum alarm clock and Chronos. So we're very happy to share this, and we also observe that there is a other projects that coming into that, so we're glad to help and share our insight and so on and so forth. Okay, so this is basically the presentation that I'm aiming to give. So obviously I'm looking for a feedback from all of you. Note that this is a very drafty version, so it does not have all the graphics and all that stuff. So this is mainly just like a content. So let's get it started. Okay, so first of all, what is an execution market, right? And as I said, we been working on the Ethereum alarm clock, which is a scheduling protocol that is using the Ethereum blockchain for holding the scheduled transaction, and they also have a execution off-chain execution network for to execute and facilitate those transactions. So while working on that, we seen that the network that we've built and we are going to release looks that can be used for the other purpose, for other projects and other protocols. And while we kind of get into this point, while we're researching different solutions, we've seen that at the basis of the execution market is the idea of delegated execution, which means that this is something similar to the gas markets, but you are just paying the third-party agent or the third-party executing agent to send the transaction on your behalf, which means that, and guys, that this is like what's happening in the Ethereum alarm clock. This is a very powerful pattern that we observe that is getting some traction, and we basically we can distinguish between two different approaches. One is something that we have in Ethereum alarm clock, which is an on-chain based execution market. So we are using the Ethereum smart contracts to represent and to coordinate the scheduled transactions, as well as the execution agents that are looking and scanning the blockchain for those transactions and interact with them. The other idea, and this is something that we are researching and working on with the Chronos, which is a second version of the protocol, is the more towards the off-chain solution, which is based on the signed messages that are then stored in the peer-to-peer network or in the storage and peer-to-peer network altogether. And then we have different situation because the users who are scheduling those transactions, they are not going to pay directly the gas cost, and this can be used well to optimize and to make the total cost lower. So as I said, we observed that some different approaches and projects are also using similar solutions and just thinking about something that we have already. So obviously scheduled transaction already mentioned Ethereum alarm clock and Chronos. We see a similar pattern for the transaction relayers in the Uport project. They allowing users without any gas, any Ethereum and tokens just to interact with their smart contracts. Also, this is gonna be probably one of the solutions for the recurring payments. So the ERC 948 or now EIP 1337. The interesting EIP 1077, which is paying gas costs with tokens and other assets for the transactions. One of the quite interesting projects that are looking into this is a project called Miximus, which is a mixer for the on the Ethereum blockchain, and they planning to use this delegated execution to decouple the proof sending from the account that is sending the proof. So in other words, you will order someone else to send the proof to the network. So this is into the more of the privacy preserving features. And the other things where actually this might be needed, and this is also emerging, are the state channels. So in general, in the state channels, this can be used as a watchtowers or the availability managers, which means that there is an assumption that two parties that are sending the messages over the state channels, they should stay online, because there might be situation that one your counterparty is fraudulent or try to cheat. But if you are not if you are not staying online for like significant amount of time, then the wrong state might be written in the blockchain. So that's where the watchtowers are. So kind of the third party agent that looks for you for the states and then reacts if that's necessary. Very similar thing, the watchtowers for Plasma, where actually the bad exits might happen, which is also the fraudulent states that can be written into the blockchain. So very similar approach. Okay, so okay, I don't know what happened, but I can't see my screen anymore. Oh, now it's just going through. Okay, guys, sorry for that. Let me go jump back again to the slides that we stopped. So as I mentioned, there is quite a lot of projects that are using or going into this idea. So I think basically from how we should not end up basically is that we have the silos, and the current situation is that Ethereum alarm clock that we have has his own TimeNode network. The whatever ERC 948 relayers have different network, and whatever other DApps or the protocol, they gonna keep up with this very similar but yet different executing network agent. So I don't think that's a good situation, and mainly why silos are bad. So in general, we see that the amount of nodes basically depends on the amount of rewards, and the amount of rewards that also is correlated obviously to the amount of the transactions that are available on the network. So then it actually implies that the higher amount of nodes improve the reliability, because you can have more nodes or more executing agents that are willing to execute the transactions for you. So that improves the network in general greatly. And third argument is that I don't really think that the protocol or DApp creator should be solely responsible for keeping up the network, which means that in our situation would be like only us providing the nodes for the Ethereum alarm clock, which is obviously not a good situation, because the centralization is the centralization factor is really low, and also that these kind of nodes are more centralized approach can essentially lead to some censorship issues. So we don't really want to do that for the protocols that are, by default open and should be working like permissionless. So this is the thing that I, think we should end up. So in general, this is something like a on the left and the right side, you see the various protocols and DApps and other applications that are going to use the execution markets. And then in the middle, we have one execution market, which is just built from the execution nodes, right? So we have greater decentralization, and the more nodes, actually it's better. As well, for the small dApps and the small protocols, it just removes the burden of creating their own network, which is not a trivial thing. That's from our experience. So again, but how can we end up there? So there are a couple of things that we need to take take into consideration. So first of all, we need to have a grid format for the delegated execution. So for both on-chain and off-chain solutions, which means that we need all these execution agents. They need to understand how to interact with those requests or orders, that are available in a different way. So obviously, the great it would be great, and obviously change and improve the decentralization would be that if we have multiple implementation for those executing agents, meaning that we are not really basing on one reference implementation, but all the teams and protocol creators, they can build their own. But in general, the idea is that we have common interface for those delegated execution contracts or the off-chain messages. And another thing is that when we talk about the multi-protocol and potentially multi-token networks, is that those executing agents need to be able to choose the rewards, meaning that for certain protocols, the reward might be in a tokens or Ethereum or whatever, but in general they would need to be able to choose and maybe just kind of filter the rewards they are interested in. So just to kind of remove the problem of spamming the network with worthless assets. Okay, so in order to get there, essentially we have three different three major group of problems that we need to solve, and that's first, incentivization, communication, and coordination problem. So incentivization, already mentioned that there is a couple of the components of the incentivization. So the first and the minimum, I think, is that whoever is going to execute the transaction should be reimbursed for the gas. So this is like minimum zero bounty situation. But since actually those executing nodes, they have the costs of running, so they might be run on on the PCs, on the cloud, etc. But this is in general that renders some costs. So I think there is a additional bounty is necessary for doing that. The bounty, meaning that like I just propose static amount of the asset. The other thing might be the rent models, and especially this is interesting, and that's something we are researching in because if you go into more of the non-deterministic things like like conditional execution, then well, you can't really know or watchtowers for the plasma or or the state channel, so you don't really know when actually the bad behavior will happen and where you need to react. So you actually need to listen for some period of time. And obviously the cost of listening for the off-chain node is different if it does need to listen for a few hours or rather like few weeks. So that's where we looking into the renting, so a amount over the time kind of models. And the third thing is that how can we incentivize those executing agents. So there are multiple assets currently available, like Ether tokens, ERC20 tokens, NFTs, etc. But I think one of the ideas that actually we also working on is the MetaPayments. So is the idea of how we call it pay to code, which means that the reward can be any executable code that can be done at the end of this execution cycle. So by doing this, you can abstract and transfer Ether, transfer NFTs. You can execute any code, which might be like reputation gain for the given executing agent or any other thing. So yeah, the second problem that has to be solved is the communication, and that depends actually on which variant of this execution market we are looking at. On-chain execution market used by Ethereum alarm clock is slightly easier because we are using the smart contract storage, and the communication is used by events from the Solidity from the smart contracts. So there is no problem with the data availability on this layer. The off-chain solutions probably will be based, and that's what we also researching, on the peer-to-peer layers plus some sort of storage. And essentially, that's gonna be a little bit more difficult to achieve. The third problem is the coordination problem. So here you see how actually it looks, how the coordination problem looks like in the on-chain execution market. So in general, schedule, the object in the center is a scheduled transaction, and then you have multiple nodes that are trying to execute at any given time. And since only one can succeed, then some of them actually are losing money. You see that in the red because the transaction get reverted. Some of them, because of those mitigation mechanisms that you can deploy, basically will ignore those transactions because they will see that's already executed, already done job. And again, there are like different ideas and approaches that can be applied for the coordination problem. We have the claiming, on-chain claiming, which is now in the Ethereum alarm clock. We also looking into the priority queues that are stake-based. For the off-chain coordination problem, which actually I think it looks pretty similar to the problem for a block producers in Casper. So might be that the random sampling might be the good solution for the problem of who's gonna actually execute a given transaction, or maybe off-chain priority queues similar to the on-chain ones, but based on the peer-to-peer communication. So yeah, that was basically the presentation. So thank you for your for listening, and just visit our links here and contact us if you have any questions.
Thanks guys for tuning in. Thanks Peter for the lovely presentation. So let's just remind the community again. So if you're anywhere in Hong Kong, be sure to stop by. It's going to be a big show. So thanks for tuning in, and see you next week. Cheers.